In the final decades of the 20th century, when satellites were scarce and computers filled entire rooms, American engineers envisioned a weapon that could strike first, strike fast, and strike with precision. From that vision came one of the most formidable and enduring tools of modern warfare, the Tomahawk cruise missile. Designed to fly low, evade detection, and navigate autonomously toward its target, the Tomahawk transformed how nations projected power. It wasn't just a missile, it was a revolution in how wars would be fought. The birth of a revolution. The origins of the Tomahawk trace back to America's determination to dominate long-range precision warfare. The idea was simple but groundbreaking. Create a missile that could hug the Earth's surface, avoid enemy radar, and hit its mark with unerring accuracy. If an enemy's radar couldn't detect an incoming strike until it was too late, their defenses were effectively useless. The roots of this idea stretch as far back as the 1940s, when the United States began experimenting with early cruise missile technology inspired by Germany's Vi-1 flying bomb. The American version, known as the JB-2 Loon, was crude but paved the way for future innovations. During the 1950s, the U.S. Navy advanced the concept further with the Regulus I missile, capable of carrying a nuclear payload. Its successor, Regulus II, was even more sophisticated, but was abandoned in favor of the Polaris ballistic missile program, which prioritized strategic nuclear deterrence. The dream of a reliable cruise missile was put on hold until the 1970s, when geopolitical circumstances changed once again. After the signing of the Strategic Arms Limitation Treaty, or SALT I, which restricted ballistic missiles but not submarine-launched cruise missiles, the U.S. Navy saw an opportunity. Engineers began developing a missile that could be fired from standard submarine torpedo tubes, giving the Navy the power to strike deep inside enemy territory from beneath the waves. From concept to reality, by 1977, General Dynamics had won the contract to develop this new weapon, outpacing its competitor Ling Temco Vought. The Tomahawk was designed not just as a nuclear strike weapon, but also as a multi-purpose system. It evolved into several variants: nuclear and conventional land attack versions, and an anti-ship model. By the early 1980s, Tomahawks were already being deployed aboard Los Angeles-class submarines and Iowa-class battleships, giving both platforms the unprecedented ability to launch precision strikes without relying on aircraft carriers. For the first time, naval ships became floating precision strike bases capable of devastating blows from hundreds of miles away. Engineering a masterpiece, the Tomahawk's design was both elegant and efficient. Roughly 18 feet long and weighing between 2,700 and 3,500 pounds, it featured a small turbojet engine, foldable wings, and a sleek frame that allowed it to travel at subsonic speeds while maintaining a flight altitude of less than 200 feet. In anti-ship mode, it could skim just 20 feet above the surface, making radar detection nearly impossible. Early Tomahawks relied on a terrain contour matching system called TERCOM, which used radar to compare the landscape below with preloaded digital maps. As the missile neared its target, another system known as digital scene matching and area correlation would take over. Using optical sensors, it compared real-world imagery with stored photographs of the target area to make minute course corrections. To ensure it functioned in darkness, the missile even carried a strobe light. Later models incorporated GPS and inertial navigation systems, further refining their accuracy. The Tomahawk's precision became legendary, achieving a circular error probable, the average distance from the target where it lands, of about 30 feet. This meant that nearly every missile could strike within a few meters of its intended target, even from hundreds of miles away. Proving itself in combat, the Tomahawk's combat debut came during Operation Desert Storm in 1991, and its performance changed warfare forever. When coalition pilots faced the threat of dense Iraqi air defenses, the U.S. relied on Tomahawks to strike heavily fortified positions deep within Iraq, including Baghdad. The missiles flew low, unseen, and hit their targets with remarkable precision. Saddam Hussein's air defenses crumbled, and the Tomahawk instantly became a symbol of American technological dominance. The success was so dramatic that the US military immediately ordered thousands more to replenish its stockpiles. In the years that followed, newer versions of the missile proved equally effective. In 1993, upgraded Tomahawks destroyed an Iraqi nuclear site. The following generation, known as Block 3, added GPS navigation, improved warheads, and lighter components that extended the missile's range to over 800 miles. These missiles saw action during NATO operations in Bosnia in 1995 and Yugoslavia in 1999, as where they were used to disable enemy air defenses and clear the way for Allied aircraft. Evolution through the generations. As technology advanced, so did the Tomahawk. The Block 4 model, introduced in 2006, brought the ability to change targets mid-flight. Operators could redirect the missile to one of 15 pre-programmed alternatives or even send it toward a completely new target in real time. Its GPS receiver was hardened against jamming, and its range extended to about 1,000 miles. Then came the latest generation, the Block V, unveiled in 2021. This version represents the pinnacle of Tomahawk evolution. It includes the Block 5A Maritime Strike Tomahawk, designed to hit moving naval targets, and the Block 5B variant with a new multi-effects warhead capable of penetrating fortified bunkers and underground facilities. One of the Tomahawk's greatest strengths is its compatibility. It fits perfectly into the US Navy's standard Mk-41 vertical launch systems, the same cells used for anti-air and anti-submarine missiles. This means it can be easily deployed from cruisers, destroyers, and submarines. Ohio-class submarines can carry up to 154 Tomahawks, while the newer Virginia-class Block 5 submarines can launch as many as 65. Few other weapons provide such a versatile and scalable strike capability. The Ukraine factor. In recent years, discussions have emerged about transferring Tomahawk missiles to Ukraine, a move that would dramatically expand Kiev's ability to strike back against Russian aggression. Such a transfer would not only bolster Ukraine's tactical flexibility, but also deliver a powerful psychological blow to Moscow. If implemented, it would mean that Russian command centers, logistics hubs, and airfields deep inside the country would no longer be safe. The Tomahawk's reach could effectively shift the balance of strategic power. However, this is no simple task. The Tomahawk was designed for ship and submarine launches, and Ukraine lacks such platforms. For ground use, the missile would require specialized launchers, possibly based on systems developed by Lockheed Martin, which adapted the Mk-41 vertical launcher into containerized ground-based platforms. The U.S. Marine Corps had also tested vehicle-mounted Tomahawk systems on the unmanned Joint Light Tactical Vehicle, proving that the missile could indeed be launched from land. Yet, technical challenges remain. Ukraine would need training, integration into command networks, and secure communication systems to operate such advanced weaponry. Still, Ukraine's record of quickly adapting to Western technology, from HIMARS to Patriot air defenses, suggests that it could integrate Tomahawks faster than many expect. A strategic shift in warfare. If deployed, Tomahawks could give Ukraine a genuine long-range strike capability, allowing it to target critical infrastructure up to 1,000 miles away. This would force Russia to reallocate defenses, move command centers deeper inland, and devote resources to protecting its rear. The psychological and logistical disruption alone could reshape the battlefield. More importantly, it would signal that Ukraine's reach now extends far beyond the front lines, creating a new level of deterrence and pressure. The legacy of a modern icon. For over 4 decades, the Tomahawk has remained one of the most versatile and effective weapons ever built. From its origins in the Cold War to its modern role in precision warfare, it has continuously evolved to meet new strategic challenges. Its ability to adapt, through upgraded guidance, enhanced payloads, and cross-platform compatibility, has ensured its relevance in an age of rapid technological change. The Tomahawk's legacy lies not just in its firepower, but in what it represents. The fusion of engineering brilliance, strategic foresight, and relentless innovation. Whether launched from a submarine's shadowy depths or a ship's vertical silo, the missile embodies the modern principle of warfare: precision over brute force. And as discussions continue about arming Ukraine with this legendary weapon, one thing remains clear. The Tomahawk is not just a relic of past conflicts, but a weapon still shaping the battles of the future. So, what do you think? Let us know your thoughts in the comments below. We'd love to hear your take. If you enjoyed this deep dive into military technology, don't forget to leave a like and subscribe to the channel. Thanks for watching, and as always, stay curious, stay informed, and we'll see you in the next one.